Okay, hello everyone. Thank you very much for joining us today for AIAA Los Angeles Las Vegas section e-town hall meeting on April 24th, Earth Day celebration. We have very exciting talks today and very good speakers. So please enjoy the event today. So this is the tentative schedule. Dr. Teixeira from JPL, he will join us around 10:30, around that time. Just a few words. Thanks to AIAA headquarters for providing this very nice Zoom platform. And also the first two talks today will be recorded, but not the one for the climate change. If you got disconnected, please try to reconnect. It should be just a temporary glitch. And if you have any internet bandwidth issue or security issue, you can try to dial in using the phone number. That will give you better stability and bandwidth. And please use your real name to sign in. And please type your question in Q&A box. The speakers will try to answer them with their best, but we don't guarantee that everything will be answered right away. Okay, so just a few words. Southern California, Los Angeles, Las Vegas section is very blessed with a lot of aerospace activities, from James Webb Space Telescope, Northrop Grumman, TRW, and Defense, Super Hornet, F-35, Router, and DL, just exciting ingenuity, perseverance, and planetary defense, astro exploration, space debris, Virgin Orbit, Virgin Galactic, and SpaceX, just right next door, and the many space students in this area, and also Aerojet Rocketdyne. And if you're an AIAA member, you can start to enjoy the engage to chat with members around the world. We have a couple opportunity next week. We have a talk by JPL Dr. Dinal, and also we are going to announce the AIAA Los Angeles Las Vegas section Excellence Award to the Ingenuity Helicopter team and the Mars 2020 Perseverance team. Membership is very important part for AIAA, so please join us if possible, and any question please ask. And AIAA just started a high school membership, so it is very good for young people. We want more people to join AIAA. And AIAA also have 5 flagship national forums for aviation, propulsion, energy, defense, ascent, and SciTech. And we have a couple events in the past month or two, to keep people engaged. So this is one related to, a little bit related to the topic today, but today is more Earth Day. February 27, we have Dr. Bradley, AIAA Fellow, leading an event on sustainable aviation, cover biofuels, hydrogen, electric hybrid, and these are the people who presented here. It is a very wonderful event. And we're doing other things, keep students together, Hyperloop, and advanced propulsion, quantum computer. We also have space architecture and minorities. And then we have the first Columbia Space Shuttle launch. And another quantum computer talk, and this is Dr. Dan Raymer is proposing a Mars manned airplane. And he has collaborated around the world. You can see Jean-Francois and from France and the people from Israel, Brazil, working for Dr. Dan Raymer. And we also have, the Vice President of Virgin Galactic, Virgin Orbit, talking about their project, and you can see there, Sir Richard Branson. So the speakers today for the first talk is JP, Jean-Philippe Renaud, is the Vice President of the Stars Up Festival. And he is, he will introduce himself better, but he's basically also a Managing Director of the American Consulting Company. JP is Vice President of the Stars Up Festival near Paris, France. This festival aims to bring together the general public and the French and the European experts, investors, and the researchers in aeronautics, ballooning, and space to reflect the future of air transport modes. This festival takes place this year at the end of June in Meudon. Yeah, sorry, there is a glitch. So
yes, we've lost the connection, Ken.
Yeah, sorry.
You were talking about Melun, a wonderful city in the western suburb of Paris.
Yeah, you will tell us more about it.
Yes, okay. Yes, I will introduce this.
Yeah, and then we have Michel Ekda. He's a science journalist at the Dépêché du Midi, and he's the granted proof of concept for the thermal reactor. He retired from French Air Force. He's an engineer, and he was working in DGA, similar to DARPA, and he holds several positions, in Paris, like radar helicopter flight test. He also have, he's also the KDOSE correspondent for the East-West technology transfers. He's doing a lot of experience, and he's also very interested in the flying car and the disruptive propulsion system with the support from the Ministry of Defense. And he in 2014 he got a famous POC for the thermal reactor with multiple applications. He also writes books, especially for human sciences. And this is just a picture of the area we are talking about, very beautiful. And you have the foreign ministry, Ministry of Foreign Affairs in this very beautiful area. So let's welcome JP and Michel.
Thank you, Ken. So let me share first my screen with a presentation, and tell me when you see the screen. So we have a 25-30 minutes presentation.
Yes, yeah, well, yeah, no problem.
You see?
Yes, I see it.
Okay. So as we have introduced, and thank you again for having us, Ken. It's a great honor to be here from Melun. As you have mentioned, it's a very small city near Paris, and you will see in the few slides that it's a birthplace of air ballooning in Europe, and it's also a place where has been built up in 1933, the first wind tunnel in Europe, and I think quite also in the world. Let's start with the bio of Michel. I'm trying to go to the next slide. I've got. Do you see the next slide or not yet?
Not yet.
Not yet.
Not yet.
Let me see. Why is there a technical issue? I did not manage to go to the next slide. Okay, here we are.
Yes.
May I have a small word to?
Yes, please, Michel.
Yes. Thank you, GP. First, I apologize for my English. Even if I was born to the White House, White House, because when you translate Casablanca, Spanish, you find White House. Sorry for this bad joke. And second, congratulations, very, very supersonic congratulations for helicopters take off from Mars. And you see, you take off from Mars, and we hope to take off from our garden. Yes, GP, for you.
Yes, thank you for this first intro, Michel. And you will see, and that's the title of this session. If you remember the title, "Taking Off from the Garden." And I remember the first time I met with Michel, it was 1 year ago. My impression was clear. Taking off from the garden is the obsession and is definitely the dream of Michel after a brilliant 40 years of career in the aeronautics. Briefly about myself, but Ken, you've done already, and thank you for that intro. So I'm living near Paris. I'm a great fan of all things around aeronautics and especially air ballooning. And effectively, I've launched with some of my friends an initiative around this Startup Festival. Startup, it's a mix between startup and stars. So the intent is to bring different experts, general public, in order to during 3 days. And the third edition will be late June in Meudon, so near Paris. The intent is to bring to the general public what will be possible for the next 10 to 20 years around a new type of transportation in space, in urban mobility, and a lot of subjects like this. Okay, so this is the agenda of this 25 minutes, 30 minutes presentation. First of all, the intent was to set the scene with a very small recap of what we call the theoretical basis around this new type of concept around the thermoreactor. Just after, we'll again recap very briefly, for sake of time, around what has been launched in terms of initiative around this famous Humphrey cycle. We will also definitely deep dive into what has been the trigger for Michel around this thermoreactor innovation. We will describe then what has been the already discussion with the global ecosystem, not necessarily only in France, Toulouse, but also at the European level, to help Michel to jump from disruptive ideas to a first proof of concept. And then we will conclude before an amazing video with what's next. So what will be the next intention and ambition of Michel to move forward when it comes to this disruptive invention based on this Humphrey cycle. And over to you, Michel, just as a short introduction around this very well-known Humphrey cycle.
Thank you. The difference in efficiency between constant pressure combustion, CPC, all current jet engines, and constant volume combustion, CVC thermoreactor, is between 15% and 30%, depending on the mixing pressure in the combustion chamber. Mr. GP?
Yes, okay. So you see the intent of this slide, just to recap the difference between the traditional constant pressure combustion and the constant volume combustion. We have found on different articles what has been based on this Humphrey cycle, what has been already presented by the famous DARPA in the US. Also, the same type of studies have been performed by the DGA, which is the equivalent of the DARPA. The same in Germany, in Canada, and India. So in a nutshell, it has been demonstrated that when it comes to this Humphrey cycle, it's a real game changer. And we have presented this as an introduction because during his career, as I said before, Michel has been obsessed by the industrial implication of this cycle in order to bring this to the real capacity in terms of combustion and a constant volume combustion. And by the way, if you double click on what has been performed during the middle of the 20th century until now recently with Pratt and Whitney, we see that based on this Humphrey cycle, some tangible researches have been performed, especially by Rolls-Royce with Purdue University in the US, in order to see how to implement this Humphrey cycle with tangible engine applicable to airplanes and so on and so forth. In order to jump to this disruptive innovation brought by Michel, I would like Michel just to share with our attendees what has been your motivation based on your long-lasting career. What has been your motivation? And I will say the trigger element, which I can imagine a morning you wake up and say, by the way, it is exactly what I have to transform when it comes to this Humphrey cycle. Could you share with us some few words around your motivation and what has been the trigger before your work around the thermoreactor?
Yes, my first tests on pulse combustion were carried out during my last year, 1977. My English, sorry, and training at the Aeronautical Engineering School in Toulouse. At that time, I was also convinced that opening and closing a combustion chamber could only be done with an alternative mechanism. GP?
So it is when, if I summarize in a nutshell, the key, let me come back to the previous slide, sorry. So the key element around this innovation is definitely what we call the alternative movement as a continuous alternative movement. That's why we have a small, and tell me if you see this small animation, potentially you have received the So tell me if you see the animation when you see, let's say, one cycle of the combustion chamber, which lasts something around 15 milliseconds. You're okay with that, Michel?
Yeah, yeah.
So you
exactly.
see you see exactly the illustration of this disruptive innovation, meaning this constant rotative movement in the combustion chamber,
Yeah,
which
the
is
most important rotative movement.
the basic of this thermal reactor.
Yes, correct.
But beyond this, let's say, theoretical basis, beyond the fact that we see that the performance of the Humphrey cycle is quite better than the Brighton cycle, which is currently governing the existing turbo reactor all around the world. Michel, could you share also what is the potential impact due to the small size of this thermoreactor engine for potential new business cases and business model?
Yes, the footprint of a thermoreactor, small size, is enough small, and we can integrate it the thermoreactor in the wing is very important because the design of the aerostructure is totally modified, and we can think in other path. You see. So sorry, GP.
Yeah, so you see, and that's the objective of those exploded view of the thermoreactor. You see that, and you will discover this later in the video at the end of this presentation. You see that, and for me, I remember my first discussion with Michel. I think that beyond the better performance, and by the way, less consumption of fuels, we think by 20% minimum. That's exactly what Michel told me, and you do confirm that from a pure fuel consumption, we are reaching a decrease of 20%. More than this decrease, which is contributing to, and then we are at the Earth Day, of course, which is contributing definitely to the global warming equation, I will say. There is also a key characteristic, as Michel has mentioned, around the feasibility to rethink and to build totally disruptive shape in terms of airplanes, due to the fact that it's possible to embed directly your engine within the wings, which is totally disruptive compared to what is currently available on the market.
And you see, GP is the big chief of our R&D.
No, okay. No, you are joking. So thank you for this transition, because, you know, especially in France, it's the same in the US. An innovation is not real if you are not recognized by your let's say your ecosystem, your industry. So could you share with us, Michel, what has been your journey when it comes to the patent you have filed starting 2012 in France?
You see, US are in US represent 50% of the world aviation. It's very important. So US delivered the patent of the thermoreactor in 2018. 2018 is very important for me, and thanks. I'm very proud. Yes, really, I am very proud of this. And Japan before in 2017, France, sure, in 2012. Yes, and Canada, it is in progress. The patents are in progress in Canada, especially. GP.
Yes, thanks, Michel. So, and beyond this, let's say, these basic patents, recognizing the technical feasibility of the thermoreactor, I know, Michel, that you have also performed additional patents dedicated to, let's say, a connex subject around the thermoreactor, especially when it comes to the drag reducer. Could you also give us some few words around that?
Yes, thanks. Very important. The drag reduction patent is very important because this is an apply as well to aircraft as to rolling vehicles, car and train. and particularly adapted to electric car so as to increase their autonomy by more than 40%. For 40%. I can explain it technologically, no problem for me. The other patent, ejector patent, in accordance with the work carried out by NASA, this injector adapt to the thermoreactor makes it possible to strongly increase the thrust at takeoff, and especially without without overconsumption of fuel nor degradation of the drag is very important. And the last yes for that time, the last patent reverse still under examination by France. This device will make it possible to increase the thrust of the current turbojet during all the phase of takeoff and rise towards the cruising altitude without overconsumption of fuel. Is very important. But it is now under examination by France and US too.
Thank you, Michel. So, in a nutshell, based on this theoretical entry cycle, after a long-lasting career of 40 years, after the first initiative around several patents and let's say a loan research after his career, what I found very interesting to raise today is the fact that Michel took also a great initiative to leverage his ecosystem. Because he's a lucky guy, because he's living in Toulouse, the birthplace of European aeronautics. So here on this slide, you see what has been done in terms of initiative by Michel and globally his ecosystem. As I will say, to start from the ideas and from the concept to a first level of development, meaning a first proof of concept. So he has launched, as we have mentioned before, initiative with the DGA, so the equivalent of DARPA in France, some initiative in order to modelize his invention and to transform the concept into a tangible engine with the help of Dassault Systèmes, which is a well-known subsidiary of Dassault Aviation in France. Again, some initiative with EADS, which is now the well-known Airbus company, with headquarters in Toulouse again. And not only some type of initiative with the aeronautics, let's say, ecosystem, but also with the Toulouse Business School in order to prepare potential new type of business model and use cases. So you see in parallel a journey around technology disruption / innovation plus anticipation of potential use cases. And by the way, if you want to continue with this discussion, we will have in November, do confirm the timeline, Michel, will be mid of November, we will have a conference in Paris around new type of urban mobility. So if you see, Michel is in the middle of this double type of reflection around new technology, but also new type of use cases aiming at, as I said before, contributing to, let's say, less polluting type of urban mobility. That's the case in Paris. I guess the same in big cities in the US. So connection with the technology ecosystem, also, and not only connection with schools and academics, because as I said, it's not only a question to work with big companies, but also to participate to the animation of the local ecosystem when it comes to school and academics in France, but not only, in Montreal, in Morocco, and in Singapore, and participation in different conferences and exhibitions in Japan. And over to you briefly, Michel, because I know you are extremely proud around what has been proposed by the Airbus BizLab Accelerator and Incubator in 2017.
Yes, I am very proud because Airbus, the BizLab of Airbus selected us from hundreds of projects 200 or 300 around. But the interest of Airbus is not aerostructure, sure, they don't need me. But the interest, real interest of Airbus was, for the thermoreactor, sure. And BizLab's goal is to accelerate selected projects, by providing assistance from various experts dedicated to each project. But this duration, no more 6 months. No more 6 months. Excuse me, I try. GP.
Yes, Michel. So now, not a trap for you, Michel, but let's be transparent. If you have a dream, and I can respect this, if you want to take off from your garden, you can imagine taking off from your garden. If you do produce the equivalent noise of the British Harrier of the US F-35, you can imagine it will be create some issue with the neighborhood. So could you share with you, the attendees, what has been the concern around the noise and what has been performed until now to find a solution to reduce the noise during the takeoff flight?
Yes. You see, noise was for me the most important problem. Yes. So we have to find a solution. Noise pollution will be less and less accepted by people living near or far. The thermoreactor has a particularly efficient acoustic reducer, as shown on this illustration. In addition, the patent on the ejector adds another layer that contributes greatly to reduce noise to the point that we will be ahead of future regulations. You see, in this you can show. You see, you can read this illustration. GP?
Yes. So now the key question. If we summarize briefly this presentation, after 40 years of career in aeronautics, after a first tentative and successful tentative with different patents in France, in Europe, in the US, with, let's say, 10 years of discussions, R&Ds, workshops, participation to incubators, accelerators, we are now at the level of, let's say, a sustainable proof of concept. So what's next? Definitely, the intention is not to stick to this first proof of concept, stage 1. The intent of Michel is to move forward, aiming at reaching a pre-industrial prototype, potentially, aiming at, as we have presented before, adding all the technologies and disruptive solutions around the thermoreactor. Correct me if I'm wrong, Michel, but your first assessment is to have something around an extra 28 months, 35 months, so let's say 3 to 5 years to reach a new plateau, a new level, and to reach this pre-industrial / minimum viable product, to be in capacity to present officially a drone version of the thermoreactor, potentially in 2025 during the Paris Air Show, and why not during the Nice Air Show in 2025 also, and why not earlier? So this is where we are. Could you add some few words around your next 6 months in terms of discussions around different topics?
Excuse me, I don't understand all, but I want to thank a lot Ken for giving us the word, and believe me, I am very proud to have participated in the Earth Day. Thanks to American Institution of Aeronautics and Astronautics. Thanks a lot, Ken. TP.
Oh, great pleasure.
Yeah, so as a conclusion, and when I was presenting Meudon, and it's not a joke, this is a photo taken from my garden, not totally from my garden with a big teleobjective, but you see so hopefully, I hope we will see you in Paris after the pandemic situation. You see on the left-hand side, you are recognize the Eiffel Tower, and you see this small, not so small by the way, this small air balloon, and we will be there in 2 weeks from now with Michel, preparing the teaser for the third Startup Festival. So we will be there flying over Paris at an altitude between 200 meters and 300 meters. So it's quite impressive. So now, as a conclusion, I hand over to Ken, just to play the video, which is a sort of a concrete dream in a video for sure, presenting a potential use case derived from this disruptive innovation with a thermoreactor. Ken, hand over to you.
Okay, can you see the screen now?
Not yet. Not yet.
Not yet?
Yes. We see the first image, but I think it doesn't work quite well right now.
Okay, I'll start playing.
Yes. Or what I can do.
Yes, that's good.
Yeah, it's good. We don't hear the sound. I don't know. Do you hear the sound? Or?
No, I don't hear.
You don't hear the sound?
No. So what I can do? I've got a plan B, Ken. I've got
don't let me try again. Let me try again.
Okay. Because the sound is quite interesting also, and the comment.
Let me know if you hear the sound.
Yes,
okay. That's good.
Loud and clear.
Or a remote area. Today, they need to reach a distant location. A 450-kilometer journey, not easily done by standard transportation. To get there in time, they make an instant booking for a capsule. A capsule chariot autonomously arrives to drive them to the nearby takeoff area, located at the outskirts of the city. At the gateway, their capsule is clipped to a wing for immediate takeoff. The capsule takes off vertically thanks to its revolutionary engine embedded in the wings. In a few minutes, they reach cruising altitude and cover the distance at a speed of 200 kilometers per hour, consuming only 15 liters of biofuel per hour. Claire and Kataro can relax, enjoy the scenery, and prepare their arrival, thanks to the autopilot and security features. Upon arrival at the intended destination, the capsule land at the gateway and trade the wing for a chariot to drive the last mile. Claire and Kataro make it to their destination in time, relaxed, ready, and satisfied.
Yes, very good.
And we are
exciting.
done. And so the next step is to move forward with Michel and potentially some other actors around this new journey, and to make Michel's dream come true.
Exactly. Yeah. So yeah, thank you so much, and please stay in touch and come back to tell us more progresses. And also remember, you say you will let us know the link and the schedule for your festival.
Yes.
We'll post it. Yeah.
Yes, I will share with you, Ken, and if all the participants are, except due to the time zone between Pacific daytime and CET, so I think there is something around 9 to 10 hours difference in terms of time zone. But I will be much more than happy to share with you, Ken, the Facebook Live address So the festival will be next 24th of June to 26th of June in Meudon, and you will see live again Michel on stage presenting his innovation. And so I will share the connection with you and your colleagues. No doubt.
Thank you so much, and wish you all the best and great progress. And come back again.
Yes, for sure. It will be a pleasure.
Thank you so much. Yeah, so we hear this is amazing, presentation about, on Earth Day. So maybe someday, on Earth, we all green, you launch, fly and land, from your garden.
Yes,
it will be very interesting. Yeah,
definitely.
So, yeah, we'll continue with this. Then we have two young rising stars, talking about their project. And this is, I think it's a award-winning project. So we actually post the article in our newsletter, I think last month. So the speakers, there are two speakers. One is Miss Christine Lin. She's a student for Mechanical Engineering Program, University of Technology, Compiègne. And she's 20 years old. She's currently studying in UTC. She's getting into Mechanical Engineering Program. She developed her passion for aviation during her 1-month internship in 2019 in the plane maintenance area. Ever since then, she has been participating in different activities involving aeronautics to deepen her knowledge. She started by passing the Aeronautics Initiative Certificate, BIA. Then she chose to be part of the association, UTCL. And this is the Aeronautical Association of UTC as the head events and then as the president. Then today she is looking for an internship in this field to have broader eye on this industry. And we also have Mr. Chiu Blaise. He's an aeronautical engineer with a double degree from University Compiègne and Cranfield University. And Chiu is a passionate, of aeronautic, and he was implicated in several aeronautical societies, helping students to take part in different activities concerning the aeronautical domain, air shows, museum, conferences. His activities helped him being selected as French International Air Cadet in 2018, supported by the French Flying Heritage Conservation Association. He's now the secretary of ORAJ and a member of the 3AF, which is the sister brother organization of AIAA. So in case you don't know, looking forward this first professional experience in the aerospace industry. So let's welcome Chiu and Christine. So it's all yours.
Thank you very much. So let me share my screen. So can you see our screen?
Yes, we can see. So thank you, Ken, for your introduction. Chuyu and I are very happy to be there, and today our subject is Be Green, Keep Flying. So our presentation will last 40 minutes with 10 minutes of Q&A. And if you have any questions, don't hesitate to submit them. We will try to answer at the end. And the last thing, we are sorry for our accent. We will do our best. And our connection is not very good, so we will not activate our cameras. So Ken has already introduced ours. We will explain to you what is the Student Award and
Non, Julien, juste. Oui, je t'écoute.
why we choose to talk about.
Je crois que j'ai fait une connerie encore, il faudrait plus. Non? Bon.
Chuyu, you can pass.
Yeah.
I think, Ken, you have to unmute Michel. He has left his mic not muted.
So we are both very interested in aeronautics, and this is why we are here. We are also French International Air Cadet, and today Chuyu is getting in the professional world, and I will be in a few years.
So why did we choose to take the User Student Awards? So actually, we won the fourth prize of the 2020 competition. So the User Student Awards is an annual international competition designed by User Society. So since 2006, every year, they propose a topic for students to awake the spirit of innovation and get closer from aerospace and defense stakeholders. So we took the competition during the 2020 year. The topic was Be Green, Keep Flying. We will try to answer the question during this presentation. If you know some students that are interested in these awards, this year competition is What Aviation for Tomorrow's World. So why did we choose to think about this topic? So actually, global warming and its accelerated evolution are concerning issues. Civil aviation is responsible of 2.6 to 3.5 global CO2 emission, depending on which document we are reading. So a 4% year growth is assumed, and without any improvement, this will lead to triple the emissions, and this without even taking other emitted gas, such as NOx, into account. So the aeronautical domain is aware of its ecological impact and is already changing with the challenge to have a zero emission aircraft by 2050. In the meantime, while writing this document, the aviation industry is facing the COVID-19 pandemic. Its weaknesses are showing up, sometimes stopping research program as the EPANIX project that would have given significant result for future aircraft. What if this situation were just the premise of what could happen to the industry if no green aircraft were designed on time to face global warming? The pandemic increases the urge of not only going towards, but actually creating an eco-friendly aircraft and making sure it is going to be the most common aircraft used in the future. So starting with a critical appraisal to determine the pros and cons of new technologies used to reduce energy consumption and help define a more environmental friendly future aircraft, operation of those aircraft with current measures and infrastructures show some issues that will need to be resolved. Eventually, changes in aircraft domain will have some social, political, and financial changes. So starting with new technologies, we will first have an approach on new propulsive energy, then switch to aircraft structure improvements, and finish with a system for this part. So aircraft are complex vehicles and are mainly constituted of a single fuselage, I mean for now, and a wing, a propulsive system under the wings or at the rear of the fuselage with a tailplane and an empennage. Current aircraft are already highly optimized, but new solutions can certainly help improve the change needed to both go green and keep flying.
So first of all, when we think about carbon emissions, we think of kerosene. So the first thing that we might change is the propulsive energy. Since the beginning of aviation, propulsion emissions decreased a lot as their efficiency improved. And according to the European Aviation Environmental Report, between 2005 to 2017, the average fuel consumption of commercial flights decreased by 24%, as you can see in the table in the presentation. Nevertheless, despite all the progress made, fuel extraction is decreasing in the world as its stock of fuel is running lower and lower. So we need to adopt new solutions. A new way of reducing emissions during flight is to change the fuel used. Today, three energies are in front of us: sustainable aviation fuels, electricity, and hydrogen. Biofuels are made from compostable waste and biomass, and synthetic are created with use of
Merci en tout cas. Allez, à demain. Allez, à demain. Salut.
liquid hydrocarbon out of CO2 and water acquired from human emissions activity, for instance. So the solution is incredible because we are using unwanted material to create energy. Biofuels and electrofuels, the last one being considered as a renewable fuels of non-biological origin, are fuels that can be used in current aircraft and can be used as a complete substitute of fuel. To keep in consideration safety of operations, we have to change power plant systems. And in terms of cost, using the same aircraft with the new fuels is economically attractive. So comparing fuels and on an energy density base, 100% use of biofuels has less energy than current jet fuel, while electrofuels are planning to obtain an energy density of 32 megajoule per kilogram of fuel, which is slightly under the current energy density of jet A1, which turn around 46 megajoule per kilogram. Despite the fact those solutions have a lower energy density than current jet fuel, it could help the industry reduce its environmental footprint. Research on biofuels and electrofuels are still ongoing, and progress is made to increase the energy density.
So if we look at the second solution to reach the ultimate zero emission during flight, it would consist in using electrical energy instead of fuel. Even if electrical motors are more efficient than jet engine, a ratio of 3, for example, if considering a brushless motor technology, batteries energy capacity are too low compared to the jet A1. So moreover, the lithium-ion batteries are made of pollutant that can't be recycled or reused yet, transferring the carbon footprints on the different life cycle stage for long-range aircraft. So if we want to take batteries or electricity and not having the issues of the battery Li-ion, we can use either nano-electrofuels technology, Li-air, or directly changing to solid-state battery. So if we look at hybrid configuration, for instance, it can be a generation of electricity combining fuel cells and liquid hydrogen, or the use of a high bypass ratio using LH2 as an onboard generator. LH2 is considered as the third lowest carbon fuel according to Safran, as it has a rather high energy density of 120 megajoule per kilograms, and emissions stay only 50 years in the atmosphere if we take in consideration only the NOx during the flight stage. So main issues are regarding its production and bigger pressurized storage at a temperature of 20 Kelvin, which is incompatible with current aircraft configuration. So liquid hydrogen is very interesting because if we take the steam methane reforming, which is not that expensive compared to electrolysis, for 1 kilogram of liquid hydrogen, there's a production of 10 kilograms of CO2, of CO, monoxide carbon. So depending on the way the propulsive energy is produced, we will have more or less footprints. So at the end, several solutions of propulsive energy are summarized in table 1, where you can see the different energy density. We can see that the liquid hydrogen is 3 times higher than the jet A1 fuel, and you can see why batteries are not very efficient yet. If we look at biofuel, is not really known, and synthetic electrofuel is a bit lower than jet A1 fuel, so that's why it's mixed with jet A1 fuel when used. Those propulsive energy can lead to zero emission flight if the process of energy production is renewable. So if we take electrofuel, it was estimated that its use in aviation in Europe by 2050, it would increase the use of electricity by 24%.
So, after changing aircraft propulsion, the second stage to a more respectful aircraft is to change its shape, as we have been using the same single fuselage ring shape for years. Now, these systems and new technologies are improving aircraft structures to reduce drag, weight, power plant, and noise, decreasing the fuel penalty and finding optimum shapes for different propulsive systems. Two concepts of aircraft have a lower drag generated during flight: box wing and blended wing body aircraft. Box wing aircraft have 2 superposed wings and a fuselage. We can also have a C configuration with a hybrid or LH2 propulsive energy, increasing the number of commercial routes. A configuration using the open rotor could help to reduce noise and fuel consumption even more. The blended wing body, also called a flying wing, has only a single trailing edge, and this reduces the drag. The length and the wide fuselage are suitable for LH2 circular tank, Those configurations are more fuel efficient than a conventional commercial aircraft with the same capacities, reducing tip wing drags and allowing a fuselage increase for the box wing and a better lift to drag ratio for the landing wing body, as it's 20% higher than the current aircraft.
So the use of those aircraft concepts can be combined with new propulsive systems. For instance, the open rotor is consuming 30% less fuel than the CFM56 or the LEAP while reducing the noise. The open rotor can only be used with fuel, so a hybrid configuration could lead to further application of this engine in the future. If we take the LH2 high bypass ratio, for instance, so it's estimated to be very efficient turbofan for long-range aircraft with good performances and noise reduction. We can also take the distributed propulsion using a ducted fan, and that could be easily implemented at the rear of the fuselage, the wing, to create a bundle relayer ingestion, decreasing the fuselage drag. So several technologies can be found. I will not be detailed here, otherwise it would be too long. So new airframe structures configuration in line with new power plants and propulsion system will definitely help to build a more performant aircraft, allowing lower particles emission and better aerodynamism. Technologies are still being characterized, but proof of efficiency are already present.
So from the beginning of the conference, we started by talking about how we can decrease aircraft emissions without changing anything. The solution was to use sustainable aviation fuel. Then to go further, we can change its shape. And now we are going to talk about the different systems that we can enhance to help us to achieve our goal. Systems in the aircraft have an important role to play in making aircraft more environmentally friendly. And depending on what propulsive energy being used, secondary power for systems will have to adapt. Today, as everybody knows, batteries are not efficient yet, and studies are helping to create a more electric aircraft. In new generation aircraft, we will find more electrical power on board and will be equipped with electrically powered actuators powered like electro-hydrostatic actuator and electromechanical actuator, which increase the efficiency and safety of systems. For example, electrohydrostatic actuator is a localized hydraulic circuit. The power needed to keep the pressure at the required level for actuation is lower as hydraulic losses are less to happen. Then the second concept that we listed for a more electric aircraft is the OLED screens. This will replace traditional windows and cockpit. Fake windows will allow a smoother structure, reducing drag and weight created because of structural reinforcement around the window. This technology offers a low electrical consumption while being lightweight, but concern should be made on the reliability of the technology and human trust and comfort in aircraft, because some people might have fears of height, so seeing outdoors can be very scary for them. Now we saw how to improve aircraft in the air, so what about in the ground? In the ground, the airplane has to be run from the gate to the runway. To ensure this function, e-taxi and regenerative landing gear is interesting as the fuels to move the aircraft on the ground are energy consuming. So why not use aircraft inertia at landing to recharge batteries and reverse this energy to perform aircraft taxi? But the problem with this concept is that it will add weight to the structures with a poor battery efficiency to store the energy produced, and it could also increase fuel consumption. So an alternative of e-taxi could be to remove landing gear systems and assist the takeoff and landing of aircraft with a maglev electromagnetic rail. In the presentation, you can see how a plane can take off and land using the Project Gabriel. Removing landing gears can reduce aircraft weight by 9.3% and fuel consumption by 80.1%, and can also reduce noise during takeoff. So to conclude, systems are being designed and are focusing on electrically powered systems, and this will change the way of how people fly as well as helping reduce aircraft consumption.
So for this first part, so the critical appraisal performed on new technologies to increase aircraft performances showed us the implication of aircraft industries to make aircraft greener. So several promising technologies and research have been made, allowing us to better understand the future of aircraft. So here we have a summary table where we gave some notes to the different technology depending on the type of aircraft that we have. So we have some military unmanned fighter, commercial aircraft, long range, high capacity or low capacity, short range, and cargo aircraft. And for each solution, we gave a note from 1 to 5. So 1 is totally not suitable, 2 is feasible but not recommended, 3 already in use, 4 suitable, need more clarification, and 5 totally suitable. So numbers were influenced by different parameters, such as the life cycle of the aerospace vehicle. For instance, a military aircraft will not have the same life cycle compared to a civil aircraft. The immediate use of the new technology, does the structure need to be changed, and the feasibility of a new technology, if it's still in the research stage, will be developed in the next section. So for next section, we will use the example of a short range low capacity aircraft like a A320, and that can use battery, nano-electrofuel, or liquid hydrogen.
So after introducing all those new technologies in the aircraft, we have to think about how we can adapt all the infrastructure needed for the new aircraft, how we will deal with maintenance and end of life. An aircraft life can be summarized in 5 steps, starting from the design, followed by the manufacture, the operation, the various maintenance, repair, altercation to achieve continued operational safety. If we lean on what we said before, a short range with low capacity import electrical aircraft can be a solution for a future aircraft. Short range aircraft are mostly affected to regional routes with a short turn times and high numbers of flights a day. The main issue with this would be charging the batteries in a short time enough to have a relevant economic model to make companies earn money. Fast charging of batteries creates heat and can damage the cells if it's not performed right. In CS 25 section 1353, electrical equipment and installations, it is stated that batteries temperature and pressure need to be the same at any time when it's used. An external cooling system will need to be found in order to not increase the weight of the aircraft during flight. And one of the solutions is to use nano-electrofuel by loading 2 types of fluid, one electrically positive and one electrically negative charged fluid on the aircraft as a traditional battery.
Concerning aircraft using LH2, first point should be made on the certification process. While no mention of LH2 in CS25 is present yet, because the technology is too soon for the moment. So like in CS25 could be explained by the different issues that are still up to date. So despite the fact that small changes in an aircraft could allow the use of LH2 in aircraft, temperature and pressure are the limiting factors, increasing thermal cycle and compromising safety of operation during refueling, for example. Moreover, if a distributed propulsion system made with ducted fan, for instance, is used on the trailing edge of the wing to increase the boundary layer, a new emergency evacuation process will need to be redefined as emergency exit from the wing will not be possible anymore. So operation of flights is going to be deeply changed by new aircraft. Choice of a new technology in accordance with mission diminution policy should be chosen in accordance with safety of operation. Moving to airport infrastructure changes. So the aviation industry can go greener if we took into consideration all the chains that includes airport infrastructures. So airports are also building that can that have aircraft and daily commuting cars. So how can airport help aviation to be more environmentally friendly? So green airports can lead to several benefits, such as an increase in biodiversity and ecosystems, improve water quality, conservation, and restoration of natural resources. Plants and microbes help to degrade chemical pollutants and organic wastes. The presence of plants attracts pollinators, which provide economic benefits to the agricultural ecosystem, as it can increase the productivity of food crops, as well as giving a good natural environmental for passengers. Airports can help reduce aircraft particles emission and noise emission using building materials, working as noise protection barriers, or encourage people to use public transportation. Alternative or renewable energy sources should be implemented and could also be combined with use of intelligent energy control equipment for lighting, heating, walkways, and escalators, for instance. These initiatives impose the installation at airports of wind turbines, biomass power plants, and intelligent energy systems, recycling facilities, and so on.
So, airport configuration changes should take into consideration the future aircraft. We will need to add LH2 facilities combining production and storage, as well as maglev rail for the Gabriel concept. A maglev rail should allow aircraft with landing gears to take off and land, as not all aircraft might use this concept. The global air transport is expected to continue its rapid growth, and at airport level, changes can definitely be put in place to reduce environmental, social, and economic impact and help the use of environmentally friendly aircraft.
Well, we were obligated to talk about the maintenance and end of life. Maintenance is compulsory to maintain aircraft airworthiness and is highly related to the end of life as the mounting processes are similar. So recycling of aircraft will help reuse material, reducing raw material extraction, impacts caused by use of chemicals and transportation. Aircraft materials or products are reused at first, recycled at second, and disposed or burned at third. So most valued part of the aircraft are the engine and the avionics, and are mainly sold for second use on the flying aircraft. So previously, aircraft was constituted of 70% of aluminum, as the A330, for example, and now tend to be composite, with the A350 using 70% of it in its structure. So as you can see on the graph, you can see the 45 years of composite evolution and the different composition materials of the Boeing 787. Why carbon fiber? Carbon fiber, they were used to reduce the structure weight and fuel penalties. So nowadays, 90% of the aircraft are valued during end of life, but carbon fiber are the missing part of this process. So this material might save several amounts of fuel during flight, but recycling of it is not possible yet compared to aluminum. New technologies might save energy and cost during flying, but the overall life cycle of an aircraft should be considered. New technologies such as LH2 and batteries, while considering the maintenance phase can be less attractive. Use of LH2 for end of life can be compared as use of Jet A1 in a way that considering that fuel is used after the flight, and then there's only left the tanks to take care of. But maintenance of them are complicated due to the low temperature and pressure, and a direct eye check will not be possible to perform. Therefore, the integrity of tanks will need to use adapted micro camera instead. For batteries are complicated to maintain and to recycle. High power used in batteries is harmful to humans, and dismantling it needs to get rid of the total stock electrical energy. Moreover, bad maintenance is quite frequent and could create cell malfunction, leading to a potential fire, which is to be avoided in aircraft. So to help reuse and recycle aircraft, aviation stakeholders launched the process for advanced management of end-of-life aircraft, or so-called PAMELA project, including research in 3 stages: decommissioning, disassembly, and smart and selective dismantling. So an Aircraft Fleet Recycling Association, the AFRA, was confided by Boeing to set up new standards for aircraft dismantling. being responsible of 150 aircraft recycled every year. And one company in Toulouse that we have is Tarmac Aerosave that is also doing some disassembly and dismantling of aircraft. So aircraft manufacturers are taking maintenance and end of life of aircraft seriously, showing good results and progress, and working in collaboration with AIAA Committee on Aviation Environmental Protection to support aircraft sustainability development.
All those improvements are helping us to fly in the future. Today it's a real challenge that we are faced with, and the COVID-19 pandemic accelerated its processes. Now we might wonder what role does politics and consumer have, and what will be the social, financial, and political impacts. And at the end, we will show you a plan for the future of transportation. So major technological changes are still in progress. Despite the urgent times, several immediate improvements can be applied on current aircraft. Before, we talk about improvements on electrification that can be done on aircraft, but it can also be done on software or onboard connected systems, which will help to acquire real-time information, and this can be very useful. For example, knowing the weather is very useful for the optimization of altitude in order to use less fuel. The optimal altitude of a plane changes along with the flight as it consumes fuel, thus its weight will decrease. Some companies such as Air France are working on flight route optimization using digital information to have better precision and reliability. Open Airlines developed a software based on data analysis from the flight recorder, meteorological data, and flight plan that enable companies to save fuel. And taxiing can now be performed with only one engine. So now, if we move to the economy part of aviation, before people would say that aviation is following a linear economy. That is to say, it takes the resources, makes the latest product, keeps it for a couple of years, and then disposes of it in landfills. This model of economy is not sustainable at all. And because it consumes a lot of finite resources and generates a significant amount of waste, pollution, and also greenhouse gas emissions. Whereas the circular economy works to reduce waste, reusing and recycling rather than wasting resources. It tries to keep materials as long as possible. The three main actions are known as 3R: reduce, reuse, recycle, and companies like Air France KLM started to adopt this strategy in their flight operations. Applying the circular economy to aviation means a focus on designing and operating for sustainability, a design for reusability, a maximization in asset utilization, and better recycling. Therefore, it aims to reduce as much as it can the environmental and social impacts, as well as to increase response to a sustainability challenge. This strategy can lead to a total modification of the supply chain from product design to end-of-life management. Some breakthroughs, such as 3D printers, are helping aviation to transit toward a circular economy, but there are still improvements that can be made to leave the linear economy. According to the ICAO report, 3D printing helped to reduce up to 90% of raw material consumption. So if we apply circular economy to airports, the easiest thing that we can do is to redesign waste management as Gatwick Airport did in 2016. This can lead to several positive results, such as reducing operation costs from saving on site energy and water up to £750,000 of Gatwick. So immediate changes mainly concern flying and operation methods. Education of aeronautical workers is the first step to reduce fuel emissions, and economical savings directly come out from this state of mind.
So we saw previously that there are different technologies. What are the changes for operational for the operation of the new aircraft, and what can what can help change aircraft and be green, keep flying. So social and political choices. So more and more human environmental consciousness is rising. Despite the fact that global warming was already known in the 1970s, where actions are recent. Sustainability is now a state of mind, a way of living, and a political direction. The aeronautical domain is facing what can be called as aeronautic shaming or fly scam. A radical approach would definitely be to not travel or buy products from other countries, but attractivity in trips and exotic items are high. Some companies started to propose an additional green increase price to compensate the flight particles emission. It was proven that consumers are ready to pay an extra price, but willingness is a factor of gender, flight range, and gas reductions. So willingness to pay an increased ticket price to reduce gas emissions is encouraging, as it will help compensate the high cost of a sustainable aircraft. So for example, the green increased price ticket, if the flight range was low, people were more eager to pay more for the increased price ticket. And if the gas reduction was high, then they were okay to pay a higher price ticket. Consumers have a high power to make things change if united, but politicians have the same power too at a different scale. Political collaboration is the key to the future. Starting on a local scale in France, usage of nuclear energy to produce electricity can help perform the energy revolution to a more efficient way of energy production, as the International Thermonuclear Experimental Reactor is trying to prove. So nuclear energy is creating debate as though insecure and radioactive, but this technology is not creating huge amount of CO2 during energy production. AIAA project will be tested in 2035, and low CO2 emission and constant energy will start in 2000 century. Changing scale and moving to the European Union with Airbus, several countries are working together daily, and Airbus proved more than once its capacity of achieving a good product from several collaborations. So batteries were found to be very low efficient and not that much useful for future aircraft, but a political call was made to create the Airbus of batteries. This collaboration will make several countries work on batteries, and hope would be that an efficient, sustainable, and moral battery is created. The world needs batteries, but moral and pollution coming from them should not be part of making a better future world. For example, some material for the batteries are coming from South Africa or from Africa, and there was the United Nations that did a warning about the usage of children to gather all these materials. So improvement can be made in the EU also by merging airspace. EU plan to reform air traffic management because of the growing traffic. The defragmenting of the European airspace will increase safety, reduce the aviation environmental footprint, and reduce costs related to service provision. Indeed, today, due to inefficiencies in European ATM, companies are facing unnecessary delays and aircraft are producing more CO2 emission than they should. This project is named Single European Sky, or SES, and was launched in 2000 by the European Commission. Thanks to this initiative, companies can plan freely their flight path, allowing more direct routes, saving costs, and reducing CO2 emission. SES concerns civil aviation, but actually military organizations demonstrated their interest in it because it will enable them to have better access to European airspace for training and operational purposes without major constraints. It represents 25% of all flights operating in European airspace, which is not negligible. EU has the power to act and define new rules in accordance with a sustainable world policy, but concern should be made on worldwide political stability. Now, the pandemic is striking the world, and how countries are dealing with the pandemic shows the different policy of different countries. Collaboration are important to combine and share knowledges, but economic and political interest, if not human and sustainable centered, could create damaging issues for the good of operation. Gross domestic product growth is one of the major objectives to have jobs and a good country economy, but it was proved that diminution of resources is not compatible with GDP growth. Decision to maintain stability in countries will definitely come from energy independency. Production of new energies such as biofuel or synthetic fuel that were presented previously, for instance, will need more biomass or electricity input. Biomass can be increased with additional farming on another country's soil, but choice of the country to feed its people or to increase its economy will then create moral issues. Flying was created by and for human beings. The world is answering to a well-known economical scheme, interest first. Consumers prove that they are ready to help in performing the sustainable transition and should be supported or outdistanced by politics, keeping moral integrity and human dignity while doing it.
Now we are going to present to you our vision of the future of transportation. Electrical vertical takeoff and landing aircraft are considered as the new urban way of transportation in cities. Uber plans to develop an urban air taxi network using eVTOL to transport people from one place to another by a ride-sharing system. They aim to create a quiet, fast, clean, efficient, and safe transportation system that is affordable for all. The issue that they meet is again the low energy density of lithium batteries, which held up long distances flight. eVTOL can replace cars, and what can replace trains and short-range flights? The Hyperloop, a project initially imagined by Elon Musk, might be a response to this question. This concept relies on magnetic levitation pods propelled at speeds of up to 760 miles per hour in a low-pressure tube. With this speed, it can connect major cities rapidly. This new way of transportation can help to reduce congestion in airports and is more environmentally friendly with its low energy consumption. Furthermore, it will use solar energy using photovoltaic panels placed on the tube, and batteries will be recharged during the braking of the train. Thanks to the high speed, Hyperloop can glide using passive maglev energy and will use only 10% of energy to initiate final velocity in the whole path. Hyperloop can be useful to transport passengers from one place to another, but for products, airships can be a good substitute too. Airship does not have a good image in our mind because of the Hindenburg accident in 1937 due to hydrogen leak, but today, new technologies can help to avoid this problem, such as the use of very resistant materials. Airship does not require polluting energy for the elevation because it uses helium or hydrogen. Fuel is used only to propel the ship forward. Thus, this way of flying will generate only 10% of CO2 emissions of a commercial aircraft. It can be used in the case where helicopters or ships could not land because, for example, of earthquakes, as airships can land even in an unstable land and without specific infrastructure. The comeback of airships might be a good thing for the economy as it's cheaper and cleaner transport than plane or boat. So after the return of the very slow, heavier than air, the return of supersonic can rekindle the flames of all aviation lovers. Boom, an American startup company, is trying to create a greener supersonic. In terms of energy, they plan to use alternative fuels to lower the impact on climate change. Tests were handled in 2019 and results show a positive way for this energy. Noise is the big concern for a supersonic aircraft, and they also have to reduce the sound of the boom when they exceed the speed of sound, which can be reduced if they adopt an optimal shape for the aircraft. It can be a promising technology because some companies such as Virgin Group or Japan Airlines have already invested in this project. Boom affirms that they can reduce the cost of supersonic flight by 75%, so the price of the ticket will be equivalent to a business class ticket.
So in conclusion of all this work to answer the question, be green, keep flying, that we were trying to answer. So global warming and its accelerated evolution are concerning issues, and aeronautic stakeholders are definitely involved and actively participating in developing sustainable aircraft, shown with several technologies and research to achieve this goal. New propulsive energy and new structures might take over traditional aircraft in the near future. It was found that depending on the operations, propulsive energy and propulsion systems would have different applications. Propulsive energy was found to be the most complicated issues in terms of technology, energy production, and density in general being low to compensate Jet A1. Using renewable energy and oil substitutes are not enough for worldwide transportation demand. Energy will be more expensive, increasing economic and social split. Economy priority will allow rich people to fly in supersonic business aircraft, while average human will stop fast travels. Political stability, consumer passion, and worldwide partnerships are a way to help this transition to lower particles emissions. Clear and transparent knowledge sharing and collaboration will allow further progress. Global warming and energy production should be the next priority if we want to keep human traveling. Note that runways for aircraft have a lower impact in terms of carbon footprint than the other transport as they need roads or rail to circulate. So supposing an optimistic approach with ITER technology working in 2000 in the world with sustainable batteries acquired from the Airbus of batteries, transportation will face lack of fuel until 2000, decreasing common transportation system and digging social inequalities while using the existing energy. The transport sector will live again in 2100 with more hydrogen and electrical vehicles. So for what we want to say is like a mix of energy until the final sustainable solution will be used. So we did a final recap in this table where we had some different provision depending on the year. So the new technologies such as Hyperloop, eVTOL, blending wing body, Prandtl plane, airship, and supersonic are all going to increase throughout the several years. For the rail and the high-speed train, for the moment, the nuclear is still helping, so they will have an average, and with the percentage of usage of this transportation mode are still going to be the same. For the conventional aircraft, the car, bus, boat that are using fuel, they will decrease as the demand for the other transportation mode is going to increase. So there's a percentage of the usage that we try to determine that are just numbers that we thought are possible, just to give an idea of the proportion of usage. For instance, the supersonic is going to be used by very few people instead of the rail or the Hyperloop or even the car that are going to be used, but using not oil, gas, but more using like hydrogen, electrical, and electro fuel. So I hope that we have give you an insight of the work we did, and we are very happy to be here. Thank you to AIAA Los Angeles. And if you have some questions, feel free to ask them. And thank you very much for your attention.
Yeah, thank you very much. Great presentation. So, yeah, it's important on Earth Day to review, the possibilities, for making things green. So, Dr. Bradley asked a question in the Q&A box. So, Dr. Bradley, do you want to speak out to mention the question?
Yeah, can you hear me?
Yes.
Yeah, my question was, I mean, you've shown us a lot of really neat technologies, and this last chart actually, summarizes a lot of the different times, so that's interesting. But which of the aircraft technologies do you think will have the biggest impact on reducing the environmental impact of aviation, if you had to pick one or two?
So we would think that first of all, the structure, not having a conventional aircraft, maybe the blending wing body, and then combining with either LH2 high bypass ratio or the open rotor. So either LH2 or batteries, solid state batteries or nano electrofuel batteries.
Yes, and the blending ring body has the most suitable shape to store hydrogen. So this can be the future green aircraft for us.
Okay, thank you.
Media too. So Helen, do you want to ask your question?
Thank you, Ken. Hello, my name is Helen, and I'm a layperson. I'm an architect, building architect. Therefore I have no education nor experience in the aerospace, aeronautical, astronautical industries. And I found your presentation extremely educational and very thorough, well thought out. Thank you so much for coming to present. I'm so impressed, and I learned something new today. And what I'm most impressed with, find the most impressionable, is how much care you put in to think about the sustainability, planet sustainability. That's very aspirational to me. And to see the younger generation, and also just there's so much tidbit of information you guys put in, this effort from the propellant energy, propellant sounds like it's a huge constraint. I'm not a chemist, forgive me for my ignorance. I'm just a layperson. But just from a layperson perspective, cost is number one. And the second aspect a layperson thinks about the most is noise. There's more of this this overhead. I'm sorry, I don't remember the terminology of this air taxis, as people call it. And people are concerned about what kind of pollution this aircraft is going to put out there, and how are they going to scare away the birds? We love our birds. And the noise level of this machines may produce, and also what are the other unforeseen negative impact to the environment this aircraft can bring about in the future. And I think you folks seems to be on the right track, and it's like you are in your research and studies. I don't have any one questions. I think I have multiple questions. And
It's
just
okay.
like what do you find the most challenging? Is there a topic you find the most challenging? You even included a slide on airport design. And as an architect, yes, we're fully aware of that. Sustainable material is absolutely important. And it has to do with what we call the MEP, which stands for mechanical, electrical, plumbing, engineering of the buildings, because building is a living organism to us. But to you, aircraft is aircraft and living organism. By comparison, how architects see buildings. I'll stop talking now. Let's just what in your research career, what do you find to be the most challenging, intriguing aspect? Thank you.
Thank you very much for your kind words. The most I would say the most challenging parts. What is funny, I mean, in France, I would say, is for people that care about sustainability and airplane lovers, is to be is to have the same vision and to work together. But if I take the subject globally, I would say is the integration and all the integration of all the transportation systems that will need and require a lot of energy. For instance, there's an Indian company that did some biofuels, and to produce the biofuels, they used 500 farmers' products just for one trip of an aircraft. So there's a lot of concern, and actually we are a bit scared that one day we will take food to produce energy. So there will be some morality, integrity to overcome this global warming situation. So I would say that it's more a human challenge than a technological challenge. I don't know if that has answered all your
No.
questions.
Thank you for sharing that. I'd like to hear from Christine. What about you? If you'd like to share.
Contrary to Chuyu, I would say that for now, the biggest problem for us is the storage of hydrogen in aircraft. I think today to store the hydrogen is very difficult because we have to store the hydrogen, we have to put it in liquid, and the temperature for this is minus 253. So this is very difficult for now. So I hope that we will find a solution for that, because hydrogen is a very good fuel, energy, because it doesn't emit any pollutants. So if we can create an aircraft using hydrogen, it can be very great for the future of aviation.
Thank you so much for sharing that. Different perspectives, definitely. And then I'd just like to say thank you again, and I'm good with that. And then hopefully we'll see more work coming from you guys. And then someday maybe I'll buy an air taxi. Thank you.
Thank you.
Thank you so much. This is a great talk. So please come back, and if we have more articles, please we can post them as well. So please come back. Talk to us about your new progresses again.
Thank you very
so
much.
Great talk. So with those